Title: 1. To determine the velocity of sound in air at room temperature by using a resonance tube. 2. To determine unknown frequency. Introduction. If a vibrating tuning fork of frequency n is held near the open end of a pipe whose other end is closed, the incident wave trains traveling down the air column are reflected from the close end with phase reversal. For a suitable length L of the air column, the incident and the reflected wave trains produce standing waves with a node at the close end and an antinode at the open end. The distance between a node and an antinode being lambda upon 4 in the fundamental mode and length of the air column is L is equal to lambda upon 4, or lambda is equal to 4L. Hence, the velocity of sound V in the air column is given by V is equal to n lambda is equal to 4nL, where n is the frequency of tuning fork and L is the corrected length of air column. According to Regnault, the antinodes are not exactly formed at the open end, and a correction called end correction E should be applied to the length of the air column and is given by E is equal to 0.3 d, where d is the inner diameter of the tube. Hence, the velocity of sound in air is determined using equation V is equal to n lambda is equal to 4n into bracket L plus E. Let us determine the velocity using a resonance tube. Apparatus. We need a metal tube open at both the ends, a glass jar filled with water, rubber pad, tuning forks of different frequencies, a stand, a meter scale, a vernier calipers, and a thermometer. Procedure. Let us determine the inner diameter of the tube D using vernier calipers. Let us first find the least count of the vernier calipers. It is given by LC is equal to value of one division on the main scale upon number of divisions on the vernier scale. So LC is equal to 0.1 centimeter upon 10 is equal to 0.01 centimeter. Zero error is equal to 0 centimeter. Zero error correction is equal to 0 centimeter. Now, hold the tube within the upper jaws of the vernier calipers. The main scale reading A is 3.5 centimeter and the coincident vernier scale division N is 4. Note the reading in table 1. Observation number 1, main scale reading A is equal to 3.5. Coincident vernier scale division N is equal to 4. Vernier scale reading B is equal to N into LC is equal to 0.04. Total reading A plus B is equal to 3.54. And corrected reading D is equal to 3.54. Take 5 more observations and note all the readings in table 1. Now, find the mean of all D. This is 3.55 centimeter. Let us find the end correction. The end correction E is given by E is equal to 0.3 d is equal to 0.3 into 3.55 is equal to 1.065 centimeter. Now place one rubber pad in the glass jar for the safety of the jar. Pour water in the jar up to its brim. Fix the resonance tube with the stand so that it is vertical in the jar. The tube should rest on the rubber pad. The setting is done. Let us find the resonating length of the air column. Arrange the tuning forks in the decreasing order of frequencies. Select the tuning fork of highest frequency. Strike it gently on the second rubber pad so that the prongs vibrate. Now, hold the vibrating tuning fork along the axis of resonance tube, and the vibrations of tuning fork should be parallel to axis, that is, in vertical plane. Simultaneously, adjust the length of resonance tube by raising it till a loud sound is heard. Please note, do not adjust the length of tuning fork when there are no vibrations in the tuning fork. In this position, clamp the tube. Now, measure the length L of the air column in the tube from the surface of water in the jar to the open end of the tube. Note the observation the same for. Calculate now mean L. Repeat this way with all the forks one by one. Note all the observations of N and L in table 2. Calculate L is equal to L plus E, 1 upon L, and the product N into L in each case, and enter neatly in table 2. Now, let us plot a graph. Take N values along the y-axis and 1 upon L values along the x-axis. Plot all the points and draw a straight line passing through the points. The straight line is passing through the origin 0, 0. To find slope of the graph, take 2 points, say A, x1, y1, and B, x2, y2 on the line. Find the slope of the line by using the formula slope is equal to y2 minus y1 upon x2 minus x1 is equal to 525 minus 350 upon 0.06 minus 0.04 is equal to 175 upon 0.02 is equal to 8,750. Hence, we get the slope equal to 8,750. To find unknown frequency by graph, draw a perpendicular from x-axis at the point 0.044 on x-axis. It will meet the axis at point P. From P, draw a perpendicular on y-axis. This gives the N dash, unknown frequency. Calculations. The velocity of sound in air, V is equal to 4NL is equal to 4 into slope is equal to 4 into 8,750 is equal to 35,000 centimeter per seconds is equal to 350 meter per seconds. By calculation, V is equal to 4 into mean NL is equal to 4 into 8,654 is equal to 34,616 centimeters per second is equal to 346.16 meters per second. Note the room temperature using the thermometer, and it is 30 degrees Celsius. N dash by calculation, N dash is equal to mean NL upon L dash is equal to 8,654 upon 21.6 is equal to 400.8 Hertz. Result: velocity of sound in air at 30 degrees Celsius is 350 meters per second by graph, is equal to 346.16 meters per second by calculation. Unknown frequency 400.8 Hz by calculation. 387.5 Hz by graph. Precautions. 1. Hold the tuning fork by its stem, not by its prongs. 2. Hold the tube vertical in the glass jar. It should not touch the sides of the jar. 3. Strike the tuning fork gently on the rubber pad. 4. While adjusting the resonating length of the air column, start with the minimum length of the air column and the tuning fork of highest frequency. So the mode of vibration will be fundamental mode. 5. The tuning fork should not touch the resonance tube.